Yeah, in this class, let us discuss given a function and you are asked to find critical points of the function, not directly solving the equations. Maybe using numerical methods you are asked to find. And let's assume the situation is also the same thing there. I mean, you may not be able to find the roots directly. For example, given a function f of x, okay, if it is a single variable function f of x, whereas if it is a multivariable function, you will have f of x1, x2 and so on xn. So given this function, how do you find critical points here? You take the derivative and you equate it to 0. Okay, now you need to find roots of this equation. Whereas here you will have n equations, dou f by dou x1 equal to 0, similarly dou f by dou x2 equal to 0 and so on, dou f by dou xn equal to 0. So by solving all of them, you are going to find a point which is a critical point of it. Okay, so now let us assume that we come up with a situation where we cannot directly solve this equation. Okay, I'll let me take you some example. Suppose if your function is f of x equal to, I'm taking the function to be f of x equal to x power 4 minus 2x cube plus 3x plus 4. So this is the function. Now the question is to find critical points of f. So this is the question. Now what do you do as a usual procedure? So you are going to take the derivative and equate it to 0, right, to find the critical points. Alright, so let us take the derivative of the function. What is the derivative? Which is 4x cube minus 2x square plus 3x, it is 3 equal to 0. Now we need to find roots of this equation. It is not quadratic to directly solve. And also you can observe that integer is not a root of this equation. You can check by substituting 0, 1, 2, 3 like that. You can check and substitute and you can check. But one thing I can tell you here, so here you are taking this f dash of x equal to 0, right? So if you see that f dash of 0, which is actually 3, whereas what is f dash of minus 1? Now f dash of minus 1 is nothing but minus 4 minus 2 plus 3. So which is minus 3, which is negative and it is positive. Okay, so now if you look at this function f dash, at 0 it is taking positive value, whereas at minus 1 it is taking negative value. It means what happens? The function is traveling from negative to positive between minus 1 and 0. It means in between definitely it has to intersect the x-axis. Okay, so it means we know some information. So the information is the critical point of this function, critical point of f of x comma y, f of x lies in the interval minus 1 comma 0. Because at minus 1 the derivative takes negative value, at 0 it takes positive value. Okay. Yeah, I wrote it wrong. This is minus 6x square, right? Yeah, thank you. Thank you for the correction. So this is minus, the derivative is 6x square. Yeah. Okay, so if it is minus 6x square, let me see if anything changes, because f of 0 is 3 only. There is no change. But here, yeah. So this is actually minus 6. So this is minus 10. So that you will have minus 7. Alright, anyway, still it is taking negative value only. So we are correct. The root lies between minus 1 and 0. It means the critical point of the given function lies between minus 1 and 0. Okay, now the question is, how do you approximate that critical point? Now you need to recall the root finding methods that you have learnt in E1. Do you remember? Bisection method, regular falsy method, and Newton-Raphson method. Okay, so here I am going to use the Newton-Raphson method. So what is Newton-Raphson method? So the Newton-Raphson method is nothing but xn plus 1 equal to xn minus f of xn divided by f dash of xn. Alright. Now this will help you to find root of the function f of x when you start with initial approximate something in this interval. Okay, or if you want me to explain how we arrived at this formula, okay, so it is just a 1 minute job to explain. So let me explain quickly. So you just start with a function. Our aim is to find the point where it intersects the x-axis. This is the point we would like to find. So this is the given function, no? The given function is f of x. Now what I'll do is, I'll make a linear approximation to the function. So linear approximation to the function, you know how will it be given by? And what is the formula for the linear approximation? So the linear approximation L of x is given by f of x naught plus, let's say at a point x naught, if you want to take the linear approximation, I don't know what is xi, so I can't write that the tangent line at xi. So let me take some other point, maybe here. So here let me take the tangent line. So let me draw the tangent line here. Yeah, so this is the tangent line. Okay, so the tangent line approximation to the given function f of x, let me write that as L of x. So L of x will be given like f of x naught plus x minus x naught into f dash of x. So this is the tangent line approximation to the given function. All right. So now, so our initial approximation to the root is this point x naught. Okay, this is x naught, and the initial approximation is x1. x1 is nothing but where it intersects the x-axis. Now to find the point where it intersects the x-axis, you need to find an x such that L of x is equal to 0. Okay, so let me try to find that. Yeah. So if you equate to L of x to 0, then what do you get? F of x naught plus x minus x naught into f dash of x equal to 0. Now you just keep this x minus x naught one side and you send everything to the other side. That is what f of x by f dash of x. Okay, now this implies what is x? Now x is nothing but this is x naught. I hope if you send it to the other side, you'll have minus here. So x naught minus f of x by f dash of x. And this derivatives must be taken at x naught only. Yeah. All right. So now this is what our new approximation x1. And after finding x1, so again you take the tangent line at x1. So the tangent line at x1 may be given like this. Okay, and you see where it intersects the x-axis. Now this is what x2. So again you're going to see what is f of x2, and here you will take the tangent line. All right, so next approximation will be here. So slowly what happens is your sequence will converge to the given function. Sorry, the sequence will converge to the root where it intersects the x-axis. So that is what Newton-Raphson method. and this is how you got this formula. All right, so now what is our interest? Our interest is to find the critical point of this function. It means we need to find 0 of this function. So our aim is to find 0 of the derivative. So if you want to find 0 of the derivative, then this is what you need to use. Xn plus 1 equal to xn minus, if you want to find 0 of f of x, we use f of x here, but we want to use 0 of f dash of x. So you write f dash of x here divided by derivative of f dash of x is nothing but second derivative at x. Okay. All right. So this is xn. Now you can simply do one thing. You start with any initial approximation from this interval. Okay. So let me take our initial approximation x0 to be 0. If x0 is 0, let me see what is f dash of x0. That is f dash of 0. What is f dash of 0 here? Which is 3. And let me calculate what is f second derivative at x. F second derivative at x is nothing but 12 x square minus 12x. Oh my god. I started with a function where I cannot apply Newton-Raphson method to it. Why? Because the second derivative is getting 0 at 0. So this is not a good initial approximation. So x not equal to 0 doesn't work. Why? Because the second derivative is becoming 0. Okay. So let me change this. So let me take x not equal to minus 1. That would be better. Yeah. So if it is minus 1, I don't know why it is not working. Yeah. So this is minus 1. Right. So what is f of minus 1 here? Minus 1 is minus 4. And this is minus 6. And plus 3. Yeah, minus 7. Alright. So now let me see what is second derivative at minus 1. So the second derivative at minus 1, is it also becoming 0? No, right? This is 12 minus into minus plus 12. It is not getting 0. Yeah, so this is 24. Okay, so our initial approximation x1 is given by x0, that is, okay, let me write it once, x0 minus f dash of x0 divided by second derivative at x0. And this is nothing but x0. What is x0 here? Minus 1 minus f dash of x0 is minus 7 divided by 24. Can someone calculate and tell me what it is? Right, so Gayatri answered it is minus 0.708. Okay, so this is minus 0.708. Okay, so if you have a scientific calculator with you, it is easy to write x2, x3 and all easily. x2, x3 without entering anything, you can simply find out x2 and x3. Okay, so how you need to do is using scientific calculator. First, initial approximation, whatever you are taking here, x0, you enter it. It means first you enter minus 1. That is our initial approximation, right? Okay, first of all, you clear everything in the calculator. First you click on AC and next you enter the initial approximation, that is x0. So enter x0. Now here it is minus 1. Okay, so enter minus 1 and then click equal to. So in the next step you click equal to. Okay, so now if you click equal to, what happens? This minus 1 and this minus 1 will be updated as answer, isn't it? So now if you click the answer button, if you click equal to, that shows you minus 1 only. Okay, so now let us go to the formula. What is the formula? Xn plus 1 equal to xn minus f dash of xn by f second derivative at xn. So this is the formula we are using, right? So now here what you have to do is answer minus f dash of answer divided by second derivative at answer. So if you click it, now the answer will be updated to the new guy. So if you click on keep on clicking this equal to, you will get the answers directly. Do you understand what I'm saying? Okay, if you consider the previous problem exactly, okay, so let me explain. After this, what do you need to do? After clicking equal to, from here, so you enter this in the calculator. In the calculator, answer, there is an answer button, okay? Answer minus, you begin a big bracket, and again one more bracket. So what is f dash of x here? F dash of x, as a function it is 4x cube minus 6x square plus 3, right? So it means 4 answer cube minus 6 answer square plus 3, okay, and you close the bracket and you click on this divided by symbol and again begin the bracket. The denominator f dash of x, that is 12x square minus 12x. You close this bracket and also the big bracket, okay, and hereafter, after entering this, now you click equal to. So this is what your x1 x0, right, minus 1. Now if you click equal to, what you get here is x1, and if you click one more time equal to, and that gives you x2. Why? Because your computer science people, no need to explain this, why it happens. The answer will be updated as x1. Now it does the same iteration with the new x1, with the new answer, and that will be updated to x2. And again you click equal to, and that gives you x3. Okay, so if you want to use Newton-Raphson method, once only you will enter into the calculator, and later to find the next values you keep on click the equal to, that's it. So I don't know whether someone is having calculator with you or not. If you have it, can you tell me what is x4? What is x4 here when I start with x not equal to minus 1?
Minus 0.597, sir.
Minus x4 equal to minus
Minus
0.597. Yeah, good. Alright, so approximately the root is this. It means the critical point, therefore, critical point of f is approximately equal to minus 0.597. That's what. Okay. So this is how you can simply find the critical points. I mean, if they cannot be found directly, if you are asked to find it using numerical methods, yeah, this is what you need to do. And this is what for the single variable function. Now what do you do it for two variable function? That also let us see. Now let us discuss about this case, a two variable or multivariable. So let me discuss about two variable, so that the same notion you can extend it for multivariable case also. Okay, so in the multivariable case, so you will be given with first of all, in whenever you have a function of two variable f of x comma y, yeah, so how do we define the derivative of this function? Now what do you mean by f dash of x? Sorry, f dash just. So now this can be equivalently can be taken to gradient of the function. Okay, and similarly, if you have let's say two functions like this, f1 and f2. So why? Because to find critical point of this function f of x, there are two functions I'm going to get. One is fx equal to 0 and fy equal to 0. Okay, by solving these two equations only we will find the critical point. So for this situation we need to know how to find approximate values of a vector valued function, or the roots of a vector valued function. So you actually have f1 of x comma y equal to 0, and similarly f2 of x comma y equal to 0. Okay, so now you are asked to find roots of f1 and f2. It means you are looking for a point a comma b where both these functions are 0. Okay, now how do you define the derivative of f here? So now let me tell you that the capital F here, so let me use capital F. Capital F is nothing but this is combination of f1 and f2 like this as an ordered pair. Okay, so whenever you take a vector valued function, its derivative will be given by a Jacobian matrix. Do you remember the Jacobian matrix? So that is what dou f1 by dou x, okay, and dou f1 by dou y, and similarly dou f1 by dou f2 by dou x and dou f2 by dou y. So this Jacobian matrix will give you the derivative of this function capital F. Alright, so now if I mimic the Newton-Raphson method for this case, so our aim is this: we would like to find an x comma y where these two guys are becoming 0. Alright, so if you construct the iteration formula here, so that will be given by xn plus 1 and yn plus 1, and that equal to, so the initial approximation that we may take it as xn and yn minus, we need to write the derivative of f. Okay, alright, so let me better write it like this. So here initially what is it we need to write? We need to write the given function itself. So the given function, that is f1 and f2, this is what, divided by derivative of f we need to take. Okay, in some sense this is how you can write this. This is xn yn minus derivative of f whole inverse this acting on f1 and f2. Okay, so and we know what is the derivative. So the derivative is given by, so that matrix we know what is that matrix, dou f1 by dou x, and this is dou f1 by dou y, and dou f2 by dou x, and dou f2 by dou y, and its inverse multiplied with f1 and f2. Okay, so this is the Newton-Raphson method for multivariable case. Alright, so for multivariable case, this is the Newton-Raphson method. Now, but what is our interest? Our interest is to find critical points of the function. It means where the partial derivatives are going to get 0. Okay, so now here what I have to do, I need to replace this f1 and f2 with fx and fy. Okay, so for fx and fy we need to find the Jacobian matrix, and I hope you know what is the Jacobian matrix for fx and fy. That will give you a Hessian matrix. Do you remember the Jacobian of a Jacobian matrix? It's like you have fx and fy, and fx and fy. Alright, so if you find the Jacobian of fx fy with respect to xy, that gives you the Hessian matrix. Do you remember? So that is fxx, fxy, yeah, and this one is fyx, fyy. So this is exactly equal to the Hessian matrix. Yeah. So now to find a critical point, so let me write it here. So to find, or to approximate, instead of saying to find, to approximate critical point of f of x comma y numerically. Okay, so let us use the Newton-Raphson method. So use Newton-Raphson method for multivariable case, and that we have seen. What is it? So the formula is going to be xn plus 1 and yn plus 1, and this equal to, so initially you write xn and yn, all right, minus the derivative of, okay, let me write it here, the derivative of fx fy, okay, inverse, the derivative, it means it will be given by the Jacobian, so inverse multiplied with f, so that f is nothing but fx and fy. Okay, so you may write it like this. So this is given by xn plus 1 and yn plus 1, and this equal to an xn and yn minus, and you know what is this matrix? That is a Hessian matrix. Let me write it. So that is fxx and fxy and fyx and fyy, its inverse multiplied with fx and fy. Okay, so in terms of notation we can write it like this. So that is x n plus 1, means xn plus 1 represents this entire column vector, that equal to xn minus this Hessian matrix inverse multiplied with, and this we can treat it as gradient of the function. Okay, so this gradient function is evaluated at xn only, and this Hessian matrix also evaluated at xn. Okay, so let us do one thing. Let us apply this to a problem. Okay, now let me take a problem here. So now the given function is f of x comma y, which equal to, let me take x square minus 2x plus 2y square minus 2y plus 2xy. So here the question is to find critical points of this function. Find critical points of f. Maybe let me insist first directly, and the second case using Newton-Raphson method. Okay, so first let me find it directly. So how do you do it? So you take the partial derivative and equate it to 0. So this implies the first one is actually 2x minus 2 plus 2y equal to 0, and the second partial derivative fy to 0, this implies 4y minus 2 plus 2x equal to 0. Maybe first equation can be simplified, and this can be simplified to x plus y equal to 1. And the second equation, this is x plus 2y equal to 1. Okay, maybe just by subtracting these two equations you can find y equal to 0. And if y is 0, and definitely x must be equal to 1. So therefore the critical point, of f, that is 1 comma 0. So directly it is clear, the critical point is 1 comma 0. Now let us do one thing. Let us use the Newton-Raphson method to find the critical point. All right. So we are done with the first part, and let us move to the second part. So to use Newton-Raphson method, first I need to calculate the Hessian matrix. What is the Hessian matrix here? That is fxx and fxy and fyy, sorry, fxy and fyy. So that equal to, I hope it is easier to see what is fxx here. And fxx to the given function, the derivative of fx with respect to x, which is 2, and derivative of fx with respect to y, that is also 2, and derivative of fy with respect to x, that is 2, and fyy, which is 4. Suppose if that is also equal to 2, then Hessian matrix is not invertible, then you can't apply that Newton-Raphson method. Alright, anyway, so now we need to find inverse of this matrix. So let me find it. So H inverse equal to, so 1 by determinant, and the determinant is 8 minus 4. So okay, let me write. So the determinant is 8 minus 4, that is 4 only, and this is 4, 2, minus 2, minus 2. Alright, so now this gives me 1 by 4 into, 4 minus 2, and 2. So we got the Hessian matrix also. Now to employ Newton-Raphson method, I hope this is enough. Maybe you know fx and fy also. So let me recall the formula. What is it? That is xn plus 1 bar, that equal to xn minus Hessian matrix inverse evaluated at xn into gradient of f evaluated at xn. Right. Maybe if you write it as a formula like this, that is small xn plus 1 and yn plus 1, which equal to, this is xn, yn, minus inverse of the Hessian matrix, we found it directly, that is 1 by 4 into 4 minus 2 minus 2, 2, and this multiplied with the gradient of the function, that is fx and fy. Fx and fy at xn, okay, at xn comma yn, and this is also at xn comma yn. This is comma. So let me write them one by one. Okay, initially we need to fix to one guess, right? Initial guess. So let me take the initial guess to be 1 comma 1. Okay, so the initial guess, initial point, okay, or you write it as a guess, which is x naught, x naught comma y naught. I am taking this to be 1 comma 1. Okay, So if you don't like it, you do one thing, you take maybe what is the critical point here? The critical point is actually 1 comma 0. Okay, you start with 0 comma 1. All right, so I'm starting with 1 comma 0. Let me see what happens. So now x1 comma y1, and this equal to x0 y0. I'm writing directly. Okay, 1 1 minus 1 by 4 into 4 minus 2 minus 2 2. And what is fx at 1 1 and fy at 1 1? We already know fx. What is fx here? 2x. What is it? 2x minus 2 plus 2. 2x minus 2 plus 2y. And fy, what is fy here? 4y minus 2 plus 2x. All right. So fx at 1 comma 1, I hope you can see that is 2. Yeah, 2 cancel and you'll have 2. And fy at 1 comma 1, which is 4. So this gives me 1 1 minus 1 by 4 into, let me multiply them. If I multiply, that is 8 minus 8 gives you 0, and minus 4 plus 8. All right. So this equal to 1 1 minus 1 by 4 multiplied with 0 4. Okay. So this is nothing but 1 minus 0, 1 minus 1. So finally we end up with 1 0. It means we are saying that x1 equal to 0, sorry, x1 equal to 1 and y1 equal to 0. And that is what the critical point, we got it right. X equal to 1 and y equal to 0. But remember one thing here, luckily in the first step itself we got the critical point. Even if you perform one more operation, you make it again 1 comma 0 only. You won't get some other different value if you start with 1 0. Okay, so in the first step itself we obtain the solution here. But in some cases it may take 2 to 3 steps to find out the solution. Alright. So if you want to know whether it is really a critical point or not, you just do one thing. Substitute these points x1 and y1 here in fx and fy. Why? Because our aim is to find x1 and y1 so that these fx and fy become 0 at this point, right? So if they completely become 0, yes, they are the critical points. No need to do it. If they are not completely 0, okay, now you go again. You go for one more iteration. All right. So this is how we can find a critical points for multivariable function using this multivariable Newton-Raphson formula. All right. So I hope you understand this problem. Yeah. Any questions or doubts here? All right. If no questions, I will stop it here.